we scientists have upheld a century. Beginning in the year 1916 for this image, one of the black holes may very well be oddities that are both fascinating and perplexing in the cosmos. They are colossal entities. In terms of gravity, yet, at the same time, practically undetectable to us. A black hole weighing between 2 and 4 million pounds times the mass of the Sun, however, based on the investigations that were carried out over the past 2 or 3 decades, we've gone from not knowing anything about them to gradually gaining a greater understanding of how closely things have recently become even more remarkable. Michio Kaku recently reported that we finally glimpsed what resides within a black hole, and this new data brings to light specifics that the field of science might have overlooked. Begin with us as we delve deeper into black holes and uncover what's hidden inside. Space is vast and awe-inspiring. What are black holes? What exactly are black holes? Before delving into the details regarding what Michio Kaku discovered, must address the fundamentals. Although most people have a basic idea of what, there are still some black holes. Gaps in the correct information. In 1916, it was Albert Einstein's theory of general relativity which predicted that, at the time, black holes were present. The concept of black holes was completely theoretical. It took another 50 years for the scientific community to find evidence that there are indeed black holes. This occurred in the 1960s when they were examining the Cygnus X1 celestial object and observed an unusually bright X-ray emitting blue star. This star was evidently not a stable entity, but circling a huge dark object. Upon further examination, it was discovered that the X-rays weren't simply moving on their own, they were being drawn into the dark object around which they were rotating, hence the term black hole was coined. This breakthrough was monumental because it provided proof that black holes actually exist and they weren't merely a figment of Albert Einstein's vivid imagination. While this discovery was remarkable, it also meant that there was an astonishing phenomenon in space that we urgently needed to understand. Consequently, scientists from all around this black became the focus of the world's efforts. Hole has been given the name Cygnus X1 and is situated within the Cygnus cluster of stars about 6,000 light-years away from Earth. It was no trivial finding. It is many times more luminous than the Sun and unquestionably compact, which imparts it with a significant gravitational pull. The gravitational attraction is so intense that nothing can escape it. Not even light. Explains why it is referred to as a concept of a black hole is both captivating and terrifying. It is a region of space where the gravitational force is so strong that nothing, not even light, is able to escape. Anything that dares too close to a black hole will be drawn. It's gone forever, but that inherent danger makes it all the more important to learn as much as possible about them. Was this the end, or were we only just beginning? The answer turned out to be the latter. Following the discovery of Cygnus X1, researchers started looking for additional black holes. They discovered that there could be nearly 100 million black holes within the Milky Way alone, but because they are so extremely challenging to detect, we still don't have an accurate count. According to all estimates, are several million black holes in the Milky Way in our very own galaxy, making them even more critical to investigate. Let's break it down by the main issue. Gravitation will always exist in black holes. Their enormous gravitational pull that anything that enters them gets compressed down to a singularity. To put it simply, black holes act like enormous vacuum cleaners, drawing everything in. One of the most astonishing aspects of the fact that black hole research exists that if someone were to fall into one, they would eventually reach a point where they become a uniqueness. In this process would unfold slowly and the person would perish before the final stage of reality takes place. So let's just say that no one should venture into one, but they're everywhere. So could we? Despite the fact that the nearest black hole to Earth is about 500 light-years away, it's still near enough to raise numerous concerns. In 2012, researchers managed to capture the first clear image of a black hole, the M87 black hole. This black hole was photographed over several nights, and the scientists fired with each shot gathered more and more evidence they had to arrange each image so that it fills they were in all the gaps in doing so, capable of determining that black hole's 3 distinct layers, and it goes beyond one vast expanding void of nothingness. As many people assume, the reality is far more difficult to reach than that. The aspect of a black hole's nothingness you have to first get through the first 2 layers, the first of which is the event horizon, which, while part of the first layer, is the final no-go area. Return after crossing the event horizon. Your only real hope is to keep moving forward. Choice, and you will be drawn into the black hole, but things only get worse. From there, the second layer is the photon sphere, in which light travels around. Any light that enters this black hole zone will be captured and can't escape, due to the black hole's intense gravitational pull. Finally, we arrive at the third layer, the singularity. This is where everything that enters the black hole is compressed cosmically until it morphs into a singularity, and the singularity is a point in spacetime where the laws of physics, as we know it, ceases to function, and we cannot predict what follows is what makes everything work. More daunting is the fact that the black hole you investigate will be completely different from the last. Sure, they generally follow the same 3-layer structure, but the way they behave could vary immensely. If this were any other object, we would simply return to our telescopes and study the basics in detail. However, with black holes, that is impractical, so researchers can only study black holes in an indirect manner by observing the heat they produce and the surrounding gas and dust. Sending a probe into a black hole is out of the question, because anything that crosses the event horizon is pulled toward the singularity, where it gets compressed into a minuscule point. So you can't just spend a lot of money on a mission that's doomed to fail, as the moment the probe gets close enough, it will be destroyed. As a result of this obvious problem, researchers have no choice but to study these objects in a 2-dimensional way, even though they are as a 3-dimensional singularity. General rule: to make things even more complex, we must also contend with the 2 problems with each black hole unique, and the breakdown of physical laws when we attempt to study the interior of black holes. Traditional scientific methods of inquiry don't exactly apply to black hole research. That doesn't mean scientists aren't busy. There are numerous theories and explanations regarding black holes, and with each new one, things become more and more captivating. One of the most persuasive theories about black hole formation is that they originate from collapsed stars. When a star exhausts its fuel, it can no longer produce enough energy to counterbalance the gravitational forces that are constantly bringing it inward, resulting in the star begins to implode upon itself, shrinking and becoming denser if the star is sufficient for this process to continue until it turns into a singularity. To comprehend the concept of black holes fully, NASA researchers turned their focus to the center of the universe, M87. Astronomers observed an extremely powerful swirl of extremely hot hydrogen gas rotating at a staggering. The sheer force at a speed of 1.2 million miles per hour of the rotating gas disk should have caused it to violently disintegrate in all directions. However, it didn't. The researchers came to the conclusion that be an enormous mass concentrated at the center of the galaxy. To prevent this from happening, this gigantic entity weighed as much as 2 to 3 billion suns, so a black hole had to be it. That isn't the only theory regarding black holes. In 1963, New Zealand mathematician Royer used Einstein's gravitational equations to give the most accurate description of a rotating black hole. He demonstrated that a black hole rotating wouldn't suffocate to a point like before previously considered, but rather into a ring of fire or a thin disk. The disk would spin so quickly that it would be outward forces would prevent its demise. This spinning disk of matter is known as the ergosphere, and it's the region surrounding the black hole where the laws of physics begin to break down. However, the most fascinating aspect of Kerr's solution was that it predicted the existence of an Einstein-Rosen bridge, also referred to as a wormhole. This is a hypothetical tunnel through spacetime that connects two distinct regions of the universe, or even two parallel universes. The concept is that if a person enters a black hole, instead of being crushed to oblivion, they would be pulled through a tunnel within the ring of fire and emerge from a white opening into a parallel universe. To understand how this works, we need to examine the idea of spacetime in Einstein's theory. The reality we experience isn't made up of independent entities but is interconnected, forming a four-dimensional fabric known as spacetime. Objects distort this fabric, creating a gravitational field that causes other objects to move toward them. Now imagine a sheet of paper representing spacetime. If you place 2 points and draw a line on the paper between them, this represents how objects move through spacetime. But what if you could fold the paper in half, creating a shortcut between the 2 points? This is the basic concept behind a wormhole. Wormholes are theoretical passages through spacetime that would allow for faster than light travel. If someone were to fall into a black hole, the idea is that they could travel through the wormhole and appear in an entirely different part of the universe. To connect this theory with Mako's recent findings, the key is in the fact that our understanding of spacetime and gravity continues to evolve with the discovery of black holes and their investigation. Their mysteries. We are beginning to investigate the very foundation of the universe itself. While we may not yet be able to travel through wormholes or directly look into a black hole's core, we've made tremendous progress in unlocking the secrets of these cosmic phenomenon. As researchers continue to explore the nature of black holes and spacetime, who knows what incredible revelations lie ahead. The universe may be stranger and more awe-inspiring than we could have ever dreamed.